Greetings, this is Tony Pizzello. Today is Tuesday, 2 in the afternoon, March 20th. I'm your professor in financial management, 5573 at Northwest University. I want to give you a few points here on week number 3. First of all, we'll take a look at the NU Online, and let's talk about the discussion post first. There are 2 articles for both the discussion post and the essay. And I want to give you a brief introduction to these 2 articles. The first one is by Stephen Brown, The Efficient Markets Hypothesis, The Demise of the Demon of Chance. So I thought it'd be good to look at another article besides FAMA. And so here is Brown, and he makes this incredible statement in the abstract, the last sentence. Indeed, a case can be made that it was the failure to believe in the essential truth of this idea, meaning the efficient market hypothesis, which was the leading factor responsible for the global financial crises. And he's referring to the global financial crises of the last recession, which started in December of 2007 and lasted until the summer of 2009. Okay, so that's Brown. And then secondly, I wanted to show you an article that is, let me see if I can find it here. Okay, here it is. This is the Les Coleman article. And this is a little bit of a negative critique on the efficient market hypothesis from a practitioner. So it says, why finance theory fails to survive contact with the real world, a fund manager perspective. In both of these articles, I would read the abstract, the introduction, and the basic first 3 or 4 pages, and then the conclusion. And that should suffice for you. Okay, now let's go on to the problems. So the problems in this week, this is the My Finance Lab problems, and I just posted, or I had them post a couple pointers on Chapter 8, both 17 and 19. So those you should be able to find on the site. At the top it says it says homework 4. That should be homework number 3. But other than that, there are two problems that I give you some pointers on. Now I'd like to give you some pointers on Chapter 7 and Chapter 9. So let's take a look first at Chapter 7. So the first one I want to look at is number 4. And number 4 says your firm is considering the launch of a new product, the XJ5. The upfront development cost is $10 million. And you expect to earn a cash flow of $3 million per year for the next 5 years. Plot the NPV profile for this project for the discount rates ranging from 0 to 30%. For what range of discount rates is the project attractive? So what you need to do here is go ahead and put in your cash flows of $3 million per year, and then the first number should be a negative $10 million for the upfront cost. And then run your NPVs. They should look something like this. I know the numbers change a little bit depending on what they give you, but you're going to have some net present value numbers and then the internal rate of return. Basically, what happens here is at any rates above 15.24%, the NPV turns negative. Okay, So this project should be accepted as long as the discount rate is below 15.24. And again, your number will change a little bit. On the next problem, problem number 7, you're going to create a graph, something like this. This is an NPV profile of the cruise ship investment. And that has an internal rate of return somewhere around 13%. I guess that was 12.72 actually on this example. Okay, problem number 13, Professor Wendy Smith. You're going to do something like this. You're going to have 12 periods. I think those are monthly periods. And the monthly rate here, 0.8484. So that's a monthly internal rate of return, 0.8484. So then to convert that into an annual, you take 1.008484 to the 12th power. So the 8484% monthly corresponds to an effective annual rate of 10.67. Okay, let's see what the MPV rule says. If you invest in an an effective annual rate of 15%, then after 1 month you will have, so now you're taking 1.15 to the 1/12th power. So the monthly discount rate would be 1.1715. And then if you compute the NPV, it actually comes out positive. So the correct decision would be to accept the deal. Okay? All right. Then the next one I want to talk a little bit about is number 17. You're going to use Excel on this one as well. Excel internal rate of return, or NPV. N is the number of periods. The present value is $1 million. The payments are negative $500,000. The future value is 0. And again, your numbers may change based on when you run the problem. In this particular case, does the IRR rule work for this decision? No, it does not. So this is just kind of a proof that the MPV is technically a little better way to go on this particular problem. Okay, chapter 8 is online, and I want to now go to some questions on chapter 9, and let's take a look at those. So chapter 9, the first one is assume Evco Inc. has a current price of $50 and will pay a $2 dividend in 1 year, and its equity cost of capital is 15%. What price must you expect it to sell for right after paying the dividend in 1 year in order to justify its current price? So in chapter 9, equation 9.1 is shown. I show it right here. It has the current price is equal to the next period dividend, div 1, plus the next period price, P1, divided by 1 plus the cost of capital. Okay? So if you look at this, it sets up the current price is 50, the next dividend is $2. X is the future price, P1, that's what you're going to solve for, and you divide it by 1.15. If you solve this for X, you get for that future price, P1, 55.50. 55.50 in the future. Okay. I want to go now to number 7, chapter 9, question 7. Dorpak Corporation has a dividend yield of 1.5%. Dorpak's equity cost of capital is 8, and its dividends are expected to grow at a constant rate. So in this particular case, the expected growth rate of the dividends, we're going to use this formula right here. The return on equity is equal to the dividend yield plus the growth rate. So basically we have 8% minus 1.5. So RE minus the growth rate, or I'm sorry, 1.5 is the dividend yield. 8% minus the dividend yield is equal to G, and that is 6.5%. So with constant dividend growth, the share price is also expected to grow. Let's take a look at that at a rate of 6.5%. So we can solve the equation from solve this using equation 9.2. Okay, and then let's go to problem number 16. Amazon Inc. pays no dividends but spent $3 billion on share repurchases last year. So basically we're going to use the Gordon model here, and it's the future dividend, which will be the share repurchases, divided by the cost of capital minus the growth rate. So the total payout next year is $3 billion times 1.065. So it's the $3 billion in purchases currently times 1 plus the growth rate. So the next dividend, div 1, is $3.195 billion. The equity value then is, you take that, $3.195 billion divided by 8 minus 6.5%. So the equity value comes out to $213 billion, and the share price is 213 divided by 0.45. So in this example, the share price comes out to $473.33. Okay, so I think these pointers should help you for the problems. Again, this is Tony Pizzolo, and I wish you the best. Go ahead and drop me an email if you need any further help. Take care.